Yesterday, she wasn't sure if she was excited about the class, but I do hope today is going to be different. Okay, so yesterday we started with our journey with automation in AWS. Started talking about Terraform, the concept around Terraform, and a few other things. Let me see if I can bring my notes up. Where is it? Okay, so there you are. And what we plan to do is to automate everything that we do in AWS, but it's not the end. After we have automated the build of our infrastructure, we still need to have a CI/CD pipeline so that further changes into the infrastructure will be able to happen in as part of a pipeline. We're not going to be doing pipeline just yet. So the plan is for us to go through the whole of building this same infrastructure with Terraform. There's a whole lot of learning around that. There is learning about how these resources are created, understanding the programming language used in Terraform, how to refactor your code, how to modularize it. There are a number of functions that you can use that makes life easy in terms of the programming that you do. So we'll go through all that. It'll take us more than today's session. So we'll probably need next weekend as well, maybe just Saturday only. And then what we'll do after that is to jump right into Kubernetes. So we'll get into containerization first with Docker and then Kubernetes, and that's going to take us a couple of weeks down the line because there's a lot to do in there. So after doing all of that, then we'll come back to CI/CD with Terraform, CI/CD with Helm, with Docker containers, and with Docker images, and as much of different components that require CI/CD, we're going to touch base on those. And then we'll touch on different tools used as part of your DevOps work to achieve different things. Tools for monitoring, tools for performance testing, tools for a lot of things, skip my mind right now, but it's just a lot of those things that we'll touch on. Okay. All right. So I hope you have pulled down the notes. So we do have our Diary Masterclass GitLab repository, and there's a note in there where I was going through yesterday. I've actually made a few more changes, updates to it, so I'll push the latest today after the class. But of course, just a quick recap about what we did yesterday. So we looked into AWS CLI, how it works, how you can create resources with the AWS CLI, introduce infrastructure as code. We started talking about certain concepts around Terraform, providers, plugins, the differences between them, what a typical CI/CD pipeline for Terraform will look like, but we'll delve deep into this at a later time. And that was about it. So today, what I'd like us to do is to start off understanding what idempotency is, and then we'll start working on Terraform as a tool. So we'll talk about the HCL language, Terraform CLI. We'll start initializing our infrastructure, start building it out, talk about state files, resources, arguments, attributes, all these things just to help you in your journey into Terraform, so that when you come across all these different things, it becomes so clear to you. You're not confused. You basically understand what's going on. But in terms of trying to understand end to end, what we are trying to do is to automate what we have done manually in AWS. Okay. Does anybody have any questions before we go further?
Actually, I just want to ask, are we going to touch on modules
Yes.
for different stages, like the staging environment, prod environment?
Yes, we will. So we will touch on modules. So before we go into modules, there are a few things we need to understand. We'll talk about data types, try to understand the different data types. We'll talk on modules, and we'll talk on different functions. We'll also talk about how to deploy Terraform in different environments, but where you will enjoy that the most is when we look at that from a CI/CD perspective. So you understand how a typical CI pipeline for Terraform would look like, and releasing versions of your code into different environments, dev, tests, staging, and things like that. Okay.
Mr. Derek.
Yes.
Yeah. Sorry, just a quick one, because I did a Git pull on this repo today, but it just like it's up to date, but I'm not seeing the update.
What branch? So did you pull on Masterclass -C branch?
Yeah.
Okay.
Because when I pulled it, it was just like it's up to date, but I did see the new update.
And you don't see week 3 folder there?
Week 3 is there. Yeah, it's there.
Okay, if it's there, you must have pulled it at some point, and it is up to date. So as long as you see 3 and this Saturday notes and all these things that I'm showing you, then it's up to date.
Yeah, but I checked, but it just like the stuff is up to date, because I was yesterday I looked at what you were trying to do yesterday compared to what is on the repo, and it's not up to date. But the repo I have week 5 on it, weeks 5 and 6, something of that nature, and it's a Masterclass C.
Okay, so this is Masterclass C, and if I push my most recent update now.
Multi-period going.
Okay. So now I have just done a push. Can you do a git pull?
All right, thank you. Let me just check.
Does anybody have the same concern? Okay, so I guess it's only.
Yes, I do. Hello, hi, Darren. Yes, I do. I have the same issue. I just did a git pull on Masterclass -C, and it's telling me it's already up to date also, after you did yours.
Okay, I don't know why that's happening. So what I would advise is you can just delete that folder, create a new one, and do a fresh clone.
Okay. Could you paste the link to the URL for the GitLab?
Yes. So let me. Okay, so this is the URL. So I'm going to share that now. I'll share it on Slack.
Okay, thanks. Expecting that.
So you can just run git clone. Sorry. All right. So let's carry on. So as a follow-up on some of the concepts that we started talking about yesterday, one which I'd like to touch on is idempotency. So idempotency is also something to watch out for. You may be asked at interviews to say what you understand about that. If you've been following along from project 1, you would have come across it, especially when you were working on Ansible. But it's actually more of a mathematical concept. So it's not specific to DevOps or IT in general. If you look at the definition on Wikipedia here, I think this is much bolder. It says that idempotence in programming and mathematics is a property of some operations such that no matter how many times you execute them, you achieve the same result. So in programming, idempotence can be a property of many different code elements, including functions, methods, requests, and statements. So what that means for us is that when we have our Terraform code written up and our infrastructure gets created, we don't want a situation where we will be scared to run our code. I'm gonna need to mute everyone, sorry. So if you're not talking, do you mind please remember to mute yourself so that we don't cause distractions, okay? So we will have to be running our code multiple times. If you're not making any changes to the code, no matter how many times we run the code, we should expect that nothing will break. If your code cannot be executed multiple times, if you have a situation where you run the code now, it creates some infrastructure, it does exactly what you want it to do, but you run it again without making any particular change to the infrastructure, and it breaks something or it tries to recreate the same things that it had created before, then your code is not idempotent. Okay, so it is very important that we find ourselves in a situation where we have a code that can be executed multiple times, no matter how many times. So you'll see that in action when we start. But just bear in mind, idempotency is a very important concept that must be achieved whenever you're dealing with configuration management, infrastructure as code, or any type of automation at all, because there will be need to run your code many times. And for each time you run it, it shouldn't break anything, okay? So let's actually start our Terraform coding. So one thing you should bear in mind is Terraform uses a programming, well, I wouldn't say programming language, it's more of a configuration language, but it uses a language called the HashiCorp language. It's called HCL. What exactly does HCL mean? I know it's HashiCorp. So Terraform HCL. It's HashiCorp configuration language. Okay, so the reason it's not a programming language, even though you can use it programmatically, it's more of a configuration language. And you'll see why that is very soon, because you basically put configuration together and send it off to the AWS API. Now, you don't directly interact with AWS API. Terraform has done all the hard work for you, and that's why it's written in Golang. So they have done all the things they have to do to connect to AWS API, and all you have to do is to write the HCL configuration language and write it in such a way that Terraform can translate it into what Amazon's API can understand, which is in the form of a payload. And once you send that off, then Amazon understands it and creates the resources that you want. So it is not the HCL that you write that Amazon understands. Terraform will translate that into some form of payload. It could be in the form of JSON or any whatever payload that Amazon expects. These are low-level details that you don't have to worry about. But what you should worry about is how to then write the HCL configuration for Terraform to understand, and Terraform takes care of all that heavy lifting. Okay, so I have my, so if you want to now begin to compare what we're doing, because I'm right now in branch Masterclass C, but if I check out into the main branch, we do have other weeks here. So if you go into week 5, for example, and go into Terraform, you see all these Terraform scripts. So for example, if I open up Internet Gateway, what you see here is HCL, okay? It has some constructs where you specify a resource, and then you specify what you want to create, you give it some name, and then it has some things in there, we'll talk about all that. But basically, this is HCL. So as we go along, I have my other screen here, which I'll then be bringing each of these. So I've numbered it in such a way that we can easily follow along. So you can see it's numbered 1, 2, 3, and all that. So I'll go back into our branch now, which is the Masterclass C. And then what we'll do is in this week 3, and there's a folder here called Terraform, I'll just be pasting those files in there from number 1 to number 2, and then we'll gradually start seeing how those infrastructures will be created. Okay. So if you want to do the same, you can have 2 separate folders. So one is you're going to clone the same repository into one folder. Then you go into a second folder, clone the same repository there. So in one, you'll be in the main branch, and the other one, you'll be in the Masterclass C branch. Okay, so that way it becomes very easy for us. So I'm going to copy a number of the files over. So let's start with the provider, and then we'll put the second one as well, which is the networking. Okay, and that's it for now. So back to our note. Now, Terraform has its own CLI. So just the same way that yesterday we could see that AWS has its own CLI, Terraform also has its own. And you know what a CLI is? It's a command line interface where you can actually type in the command on the terminal and it responds to it. So it's one thing to write Terraform HCL like this, the configuration file. It's another thing to interact with Terraform from the CLI. So it has a number of CLI commands. So for example, if I type in Terraform, you would see that it has a number of, it has some main commands and there are some other commands. So the ones you will get to use most frequently will be the init, the plan, the apply, and the destroy. Okay. Now, what the init does is to initialize your infrastructure. So you've written your HCL, and now you want to begin to deploy the resources, to create the resources. Okay. Now, you have to initialize that. And part of the things that initialization does is to understand what provider you are using. If you're working with AWS, it initializes it and then downloads the plugin for AWS. Remember, we talked about providers and plugin yesterday. Then if there are modules, we will talk about modules later on. But if there are modules as part of your code, your HCL, it downloads all the modules as well. Okay, so that's basically initializing the infrastructure. That is the part where it also tries to connect to your AWS account. So it will evaluate the authentication that you have configured. If there's a problem connecting to your AWS at that point, the initialization phase will let you know, and it will fail and say permission denied or something like that. So we will be running these commands: Terraform init, Terraform plan, Terraform apply, Terraform destroy. We're running that from time to time, and these are CLI commands. Now, over time, as you continue to work with Terraform, you would also experience other commands, all these other commands: Terraform console, formed, get, graph, imports. Yesterday, someone asked a question that made us to talk about imports yesterday. So if you have that use case, that requirement, that's the part where you would get to interact with that, So it's part of all of the commands because it's not something that you will be doing regularly. Okay, so but with these main ones, you get to interact with them most frequently. Okay. All right. So back to our notes. Now, there's something else I want to quickly talk about before we begin our initialization, which is the resource, arguments, and attributes. So I'll talk about them initially. They may be a bit confusing initially, but then when we start working with them, it becomes a lot clearer, okay? So we go back into, let's take the networking, for example. So this part of networking is the part where we create our VPC. And from our architecture here, one of the, okay, let me just save this. So one of the first things we did when we were doing this manually was to create the VPC, okay, the virtual network, okay? Now, to do that in Terraform, you would write a construct like this. Now, you see the first thing on the left here says resource. So any resource you want to create, that's the first thing you have to type out and write out, resource. And then you give the particular resource that you want to create. So this is not something that you type out. This is something that Terraform has provided that you have to use. What goes after that is going to be the name of this resource that Terraform is going to use to identify this resource that you're creating. Okay, it is not the name of the resource in AWS, so don't confuse them. This is just the name you give to this resource as far as Terraform is concerned. So Terraform is going to use that to identify this block of code, okay? And then you have an open and close curly bracket. So within this open and close curly brackets, you then have all the configuration you need to have for this specific resource for VPC, okay? And then everything that goes in here is called the argument. So you remember here, what we are trying to talk about is we've seen what a resource is in the Terraform block of code. Then the next thing is the argument. So the argument is whatever goes in here. So these key value pairs. So there's a key and there is a value. So these are arguments that you're passing to Terraform. Now, if you remember from yesterday, when we ran this AWS CLI, it is very similar to all the things that we pass into the CLI. We pass in a region and give it a value. This is an argument to this AWS CLI. So there is the filter argument. There is the count argument to give you how many we want. There's the instance type argument. All these arguments, the way Terraform represents them is in the form of a key value pair like this. So anywhere you see argument, you know that it has to be within this block of code, okay? And then there is attributes as well. If you also remember, when we ran this command yesterday, it gave us an output which represented metadata of that resource that was created. Remember that JSON output that came up on the console? Everything about that output is basically what Terraform considers as the attribute. So those are the attributes of the resource that you've created. And Terraform does a good job of keeping that information somehow. So we'll talk about how it keeps it soon as well. But it keeps that information so that you can use it to reference things. So if you're creating another resource and you want to make reference to a different resource that was created earlier on, and it has some attributes, you can then make reference to those attributes and say, I want to reference that attribute because I need to do some further manipulation or any kind of programming on top of it. So like I said, it may not be that much clear right now, but when we now start creating these resources, you now get to see those attributes and arguments and all that, okay? Now, you may now also start wondering, well, how do I get to remember all of this? Do I have to begin to memorize what arguments to use? How do I even know if I want to create an EC2 resource, for example? How do I even know that I have to write something like this, resource, and then the next part that represents EC2? How do I even know what it's going to be? Is it just going to be EC2, or is it also going to be something like AWS underscore EC2, just like this one? You don't even know if that's going to work, and then give it a name. Let's say we give it a name like that, and then open, close brackets, and then start putting arguments in there. But how do you know what arguments to put in there? Well, you don't have to try to memorize anything. All you need to know is whenever you want to create a resource in AWS with Terraform, you just go to their documentation. So let's assume we want to create an auto-scaling group, okay? So you can just put in Google Terraform auto-scaling group AWS, something like that. And then it basically takes you to Terraform's documentation. And then if you click on that, this is where you now have to read about how to use this resource. And Terraform has done a fantastic job putting examples that you can literally copy, paste, okay? So going through this documentation, you can see here, if you have to create a resource before the one that you're interested in this case, you're interested in auto-scaling group, and maybe it has some dependency on another resource, Terraform would have told you, and the documentation is your go-to place to read and understand exactly how to use this. So it's very important that you read these and the notes there as well. Take the time to read them just to understand how to use them, okay? But another part is when you scroll down, you would see there is the arguments reference section. So for every argument that will be required in that resource that you want to create, this documentation will tell you the ones that are optional, the ones that are required. So if you have to use an argument and you just can't skip a particular argument, then it means you have to specify that argument and give it a value. And it also gives you a description of what that argument is about and what they expect you to put there. So in the case of max size here, it says the maximum size of the auto-scaling group. And we do know that in AWS console, auto-scaling groups require the minimum size, the maximum size, the desired size, and all that. Okay, so let's see if there is desired as well. Let me just search for it. Desired. Okay, so we can see there's desired capacity, and there will be the documentation part of it as well. The arguments reference section. So that's that. So basically, you know, it's a very, very important thing to bear in mind that Terraform's documentation is your go-to place for any kind of resource. Now, we can't talk about all the resources that you can possibly create in AWS. Okay, there's just a lot, all right? So if you find yourself in a situation where in the real world, you have to create certain resources, this is the AWS provider. It has all the different resources that can be created, and they've written them all in alphabetical order. So you can just go all the way down. If you want to use it with CloudFormation, CloudFront, if you want to work with Direct Connects, if you want to go to the VPC section, I'm sure it will be somewhere down, or maybe it's called, if you want to work with Route 53, if you want to work with RDS, it's all there. So if I were to work with RDS, these are resources. Now we'll talk about data sources as well. Okay, so you can have resources, you can have data sources. So this is something we'll talk about somewhere down the line as well, especially when we start working with modules. But to create an RDS instance, for example, if you click on this, it takes you exactly the same format of the documentation. And if you scroll down, you can pretty much take the block of code as an example, paste it, and then just start to update it with whatever values that suits you. So if the instance type that you want to use for your RDS, it's not the example they've given, you just basically replace it. And in this case, for example, the name of the database, the username, and the password. Now, this is where your role as a database now begins to come in, because sometimes you get an example like this, but it just doesn't make sense to start putting password as part of your code, because this is going to be checked into a repository. And even though your repository is private, it's not private to the point where you're the only one that gets to see it. There are other people working in your company that will have access to see things like that. So you definitely don't want to put password there. How you as a DevOps engineer will now use best practices to ensure that you do not put passwords in your Terraform code is a different conversation entirely. There are a lot of options for that, and I'm sure going to show you how things like that gets handled at some point in the course of our training. But for now, our focus is understanding Terraform, understanding how to work with it, how to create resources with it. Don't right now focus on, oh, my code has to be perfect. The most important thing for now is knowing your way around it, okay? Not trying to memorize anything, but just to understand where to get help, how to use it, things like that, okay? So what we're going to do next is to now initialize this infrastructure. Okay, let's see. Okay, and then we'll talk about state file. So, but let's see. Okay, so I'm now in the Terraform folder where we have this provider and networking. So let's have a look at the provider, the way it works. So the provider section is where you specify which provider you want to work with. So you put in AWS here. If you were to work with Azure, GCP, or whatnot, this is where you do the configuration, okay? And then it has different arguments as well that you can pass in. So for example, region, you specify what region you want these resources to be created. And that's it with provider. Then there's another part of the initialization that is also very important called the Terraform. So this is where you configure the backend. What I'm going to do for now is I'll remove this backend. Okay, let's remove this backend for now and just save that. So this has an argument that you can pass that says required version greater or equals to 1.1.7. So this is just a way to ensure that when people in your team are running Terraform, they run it based on the version that you expect them to, because Terraform releases new versions all the time, probably every week. Okay, so the fact that you downloaded a version 1.1.7 today does not mean that tomorrow, if you try to download Terraform again, the latest version is going to be this. It would have changed to 1.1.8. And in, let's say, 2 months, you'll find out that it has moved on quickly. And usually there are breaking changes that get shipped along when they release new features. So one of the ways to ensure that anytime anyone in your team is running Terraform, you don't want a situation where they're running a version that doesn't work with your code. So you can use this as a constraint to ensure that Terraform would only work with this version. So what's going to do is it will check, first of all, what version you have installed. So in my case, I have the 1.2.2 version installed, which I downloaded, I think, 2 days ago. So they may have introduced a different version even higher than this, but at least this will help us to say, okay, it would only always be any version greater than that. So I can actually update this to 1.2.2, okay? And then I can run the Terraform init command. So if you notice what's going on, it's saying initializing the backend, initializing provider plugins, and it's finding the latest version of HashiCorp AWS. So that's the plugin that it's going to download for this provider, AWS, okay? So it's going to install that. And once it's done, it's going to create a folder locally, and we can then go through it. It's taking a bit of time. It doesn't take that long. Okay, now it's completed. Yes.
Can I ask a question, please?
Yes, shoot.
Yeah, can you lock the Terraform version to a particular version, like locking it from 1 point something, like from then above?
If you say lock, isn't that what we've just done? We've literally locked it to say only work with it.
Hello, let me point you to something. The terraform.log.hcl also locks it's just like your package.json if you know how to program in, let me say, Node.js. It locks, it install all the versions of your plugins are stored there. And whenever you run the code to use the version of plugins there.
So if you open this terraform.log file, for example, you can see what he's talking about. So the provider that gets downloaded, it's written that information here, what version, the hash, and that's it. So if you had more things like modules, whatever it's downloading, this is where it keeps that information. It's also created a hidden folder. If you open that up, let me see if I can open this up right here. Okay. All right, so in the .terraform folder, you'll see there is a folder called providers. It creates another folder, registry.terraform.io, HashiCorp, AWS 4.18.0, which is the version of the plugin. And then the version of the plugin that works with the architecture that I'm running is there. So this is the Golang plugin that's been downloaded. It's actually a program that was downloaded, and that's the one that works with AWS. So we were working with multiple cloud. This is where it will download all the plugins, because you can write a Terraform to work with multiple cloud platforms, and they can interact together, work, like build out a hybrid type of infrastructure, and everything works nicely together. Okay, so that's what the initialization does. And if you've completed project 16 and you're working with 17, 18, I think up until about 19, you know, all of these things are well documented there as well to understand how to even work with it. Just in case I even miss out on some of the information, please ensure you do not miss out on, you know, those projects. Very important. Okay, so now that we have this initialized, the next thing is to run the other part of the CLI, which is to plan out our infrastructure. Okay, so if I run Terraform plan, let's see what happens. So if I scroll up, you notice it says that this will be created. Now, when I was going through this piece of code, and I say that this is the resource resource name given by Terraform that you have to specify as part of the resource block, and then a name here. It could be anything, and this is not the name that the infrastructure is going to have in AWS. This is actually a name that Terraform is going to keep to itself to keep track of this resource. The actual name that it's going to have in AWS is this tag section. Very important so that you don't confuse this name here with the actual name of the AWS. So all that AWS cares about is all the arguments that you're putting in here, because all this argument is what you can think of it as transcribing all these arguments into the same arguments you would have provided if you were running it with AWS CLI. Okay. And then the output here tells you AWS.main, AWS VPC.main, which is how Terraform sees this resource and says it will be created. And then these are the arguments that's been passed in. But you observe also that it is not all the arguments that you specified that is coming back out to you. That's because some of those arguments have default values. And that's why from the documentation that I was showing you earlier, some of them are optional, some of them are required. So for those that are optional, if you didn't specify them, what it means is Terraform will help you to put the default values. And most of the default values also come from AWS, because AWS, you can imagine when we fill out some of the forms in AWS trying to create a resource, some of them we just leave them as default and we don't touch them. That's because they have default values. And the same thing is going on here. In some cases, Terraform can decide and say, okay, what we think should be default is a different value from what AWS thinks is a default. So I've seen that happen sometimes. So sometimes Terraform uses a different default setting that is different from what you would have used if you were creating it directly from AWS, okay? All right, so this is our arguments. And if we run this now to create this resource, let's give it a name, Masterclass. Let's just say Masterclass -C VPC, so that when we go into AWS, we can get to see that. Now, when Terraform started, the way it worked was you run Terraform plan, and then you run Terraform apply, which would basically just create the infrastructure. But nowadays, Terraform apply works like you're doing both plan and apply together, because it will initially run the plan again, and then it will prompt you to say yes or no. So this is just like another way of being careful, because you have to be very careful with things like this. You know, when you start creating infrastructure, you would begin to see how important it is to be careful with this. And that's why it's very important to also have pipelines, continuous integration pipelines, where your developers are working, or you as a DevOps engineer, you're trying to update the Terraform code to create a new resource or improve on the infrastructure, or whatever you're trying to do. You do all that in your feature branch first. You don't do it directly in your main branch or master branch, okay? So in your main branch, the way your pipeline would work is that's where the plan occurs. And then when it's time to apply that into your infrastructure, which will only go through from either the master branch or a tagged version that you're releasing, then that's where you do the apply. And even your CI pipeline can still prompt you to go ahead and click yes before you eventually do the apply. And that's where the continuous delivery comes into play. So we'll still have a session dedicated to continuous integration and delivery, and you see it in action.
I have a question. I have a question on that, on what you just said.
Yes.
Like, because I'm done with, like, I've done most of the Terraform projects. So in one of the projects, I noticed that like especially project 17, I did a plan and the plan was successful. So I felt I have finished like all the resources I was supposed to create. It was successful. I felt I've finished the project, but the next project, when I did an apply on that same project, it came up with errors. So sometimes it's always good to do the plan and apply together so you are sure that everything works perfectly.
Yeah, so I mean, the fact that you did a plan at first and it tells you that, oh, everything is green, it's going to be created, it doesn't mean that when you start doing your apply, 100% it's going to succeed. Okay, most of the time it will succeed, maybe 90% of the time or 95% of the time it will succeed, but sometimes when you now start doing your apply, it won't succeed. And that's because some things Terraform is not aware until it starts doing the actual apply. As you can see here, it says known after apply. You know, the value for this known after apply. The let me take an example. For example, default security group ID. So let's say the security group ID, okay, that this VPC is going to have at the time of doing this, it says known after apply. All right. Now, let's assume that this security group does not exist. This is just a hypothetical example. It doesn't exist. But when you do the plan, Terraform would assume that it will exist. And that's why it is known after apply. So it will tell you that, well, according to your plan, this is going to work. To the best of my understanding, these are the values for your argument, some of which I don't know yet, but I'll know it when the apply is complete. Now you start the apply, and then it figures out that this security group does not exist. Then it fails, and it shows you red, and it gives you the error message and say, oh, you're trying to attach a security group to something, but it doesn't exist. So yes, you know, it works like that. And going away from how they started Terraform, you can actually safely run apply without plan. Well, I guess they have left the plan there because sometimes all you just need is just to know whether something is going to change in your infrastructure or not. Because sometimes all you're doing is a refactor. You're not actually changing any functionality. So you expect that there'll be no add, no change, no destroy. So there's no point running apply in that case because all you just want to know, you just want to test, is my infrastructure going to change? So in that case, running a plan makes sense. But in most cases nowadays, you know, after all the different releases of Terraform, you can actually run apply safely because you know that it's still going to prompt you before it proceeds to do the apply. Okay. So in this case, I've looked at it. I think I'm okay. I can just type in yes and allow Terraform to do its thing. So now it's creating the resource. It's now talking to AWS. And then if we go into the AWS console, let's go into the Virginia region. PPC is actually where we intend to go to. Okay, we'll come back to that shortly. So let's see.
Hello, Gary.
Yes?
Just have a quick question. I'm thinking in the course of creating those resources, I think there should be like, is there anything like a sequential provisioning of resources whereby we can actually see what's going on while we use command Terraform plan?
So if what you're talking about is to understand the plan that Terraform is is going to basically, because there's something called the, when you tell Terraform to create resources for you, it actually creates like a graph of how it will go ahead.
Yeah, that was something like that.
Right. So we'll talk about that later, because I don't want to start introducing, complex things when, some basic concept has to be understood first of all. Okay. We're still trying to create the resources one at a time. And then, we'll get to a point where we need to understand the dependency, because sometimes some resources have to exist before other resources. So for example, in the case of EC2 instance, right? Your EC2 instance needs to have some security group configuration.
Yeah.
Now, if you've written your Terraform to use a particular security group, okay, and you've configured that security group in another part of your entire configuration, you've now also configured your EC2 creation as well.
Okay.
Terraform has to understand that it needs to create the security group first before attempting to create the EC2 instance. Otherwise, what will happen is it creates the EC2 instance, then it realizes that security group should exist and it doesn't exist, then it fails. So Terraform will come up with a plan to say, okay, I have to do this first before I do that. And that way you don't have to really think about it. Now, Terraform is smart enough to do things like that on itself, but you can still help Terraform by telling it the dependency. Okay, so there are arguments you can still pass into your block of code to tell it that, okay, this resource depends on that resource, and but we'll get to see all of that. I don't want us to, go into concept now, okay?
Mr. Dari.
Yes.
Please, can I ask a question? It just align with what Mr. Yemi asked just now, because I was asked the question in the interview. They said, how did you know, or how did you check your resources in Terraform before you applied them? How did you see the resources to check these resources tally with what you have before you apply them?
So, well, I mean, the easiest answer to that is Terraform plan.
But I told him I said it's Terraform.
Sorry, because at this question I was asked in the interview, that's why I asked, and my response was through Terraform graph.
Yeah, I said Terraform plan. The man was like, apart from Terraform plan, is there no other way? I said it's only Terraform plan that I know.
Maybe it was talking about state plan.
No, the state file was quite different, because they asked me a question concerning state file again, because the man was like, when I said Terraform plan, he said, you mean you check the plan visually? And I say, yes.
Yeah,
so,
okay.
I mean, because...
Yeah, go ahead.
Okay, well, I was just going to say that, because sometimes interviewing is a very, very... It's an art on its own, okay? It's a very, very complex thing. And what I mean by that is sometimes the interviewer is thinking of something and he's speaking out something else entirely, and it confuses the person that he's interviewing. And to be honest, sometimes, it doesn't mean that the person you're asking things does not know what you're asking. Okay. And that's where some interviewers, if you see some experienced interviewers, they are not playing a witch hunt game. They're actually trying to find the best person to employ. And if they figure out that you're smart enough, you probably just not understanding what they're asking, they can help you to understand better. So in this case, for example, if you answered Terraform plan, immediately that should show to the interviewer that, okay, well, you sort of understood what he's trying to say, but he could go further and explain to give you more insights in terms of what his expectations are. Because it could be, someone else mentioned state file, for example. It could be a case where there are Terraform CLI commands you can run to check in the state file what resources are there. Okay. But this is not something you get to do all the time. So I wouldn't expect someone to start telling me about running Terraform state commands, because the times you want to do things like that is maybe there's a drift and you're trying to troubleshoot things. You just want to check what's inside the state file without downloading it and looking through the JSON. You can just run Terraform states just to see what's going on in there. Okay. But in this case, what you've explained, it sounds like you just want to see the plan, but it could also be what we talked about the graph. But again, this is not something you get to do all the time. You can't be going through if you've seen the graph, you understand that it's usually a very verbose thing, and you don't want to spend your time going through things like that, So in some cases, you can even ask the interviewer, well, you've said to the best of your understanding, but if he can explain a bit more, maybe that will help. I think someone mentioned that he has the same experience too with an interview.
Yes. To buttress what Nick actually said, when they asked me that question, and I did what I said was after I run Terraform plan command, in order for me to see what resources are going to be created or provisioned, then what I needed to do to run Terraform graph. Said, and I asked question if I got it, if my response was right or wrong. They did say that was what they were expecting. That's why I tweaked.
So they were expecting you to mention the graph.
Yes.
Yeah. So that's why I said, like, sometimes you just have to throw the question back after you said it to the best of your understanding, because the interviewer may just want to trick you, may just want to do whatnot, but again, Terraform graph is not something you get to interact with all the time. But again, it might just be a case where they just want to know whether you know it.
Right.
And I can assure you, you can get a job now, and throughout your entire career there, you may never even use the command.
And I would like to share that I did get the job.
Nice. Nice. That's good. Congratulations. Is that where you're working right now?
Right now, yes.
Okay, good.
It's actually with the F-35 project with the US government, the F-35 fighter jets project.
Oh, nice.
With Lockheed Martin, yes.
That's good. Congrats on that. Okay. So again, all these things, these commands and all that, the more you work with them, the more you interact with them, the better you become, the more exposure you get, the more understanding you get. And, Terraform is not one of those things that you learn once and then you move on to another thing. It's a continuous thing. And to be honest, not just Terraform, everything. I know it's hard to keep up with all these technologies. You learn Terraform, Ansible, Docker, Kubernetes, just a lot of them. But as much as you can, you just touch on the most important ones. If you have found a job and you're working already, the ones you use in your company, be very good at them. Focus your attention on those ones. If you're still looking for work, the most popular ones in the industry, like I always say, in all the different categories, you want to focus on them. And then when you get a job, even if they don't use some things that you have been learning, then focus on it. Because you might get a job now and all they use is CloudFormation. Yes, they hired you because you have the Terraform skills, but they may also hire you because they just believe since you know Terraform, it's easy for you to pick up CloudFormation. So at that point, you don't want to spend your time learning Terraform. You want to spend your time learning CloudFormation, at least during the time you are in that company. Okay, so that's the best way to do, because you want to make sure that your impact is felt as well when you're working within anything. Okay, so
I have a question. So I just want to ask, can Terraform handle things like they have not checked the resource list to find out things like QuickSight, provisioning QuickSight, and AWS Glue?
QuickSight.
AWS Glue and something like Athena. Is it possible to do something like that with Terraform?
You can do literally almost everything with Terraform. Like I was showing you here.
Oh, okay.
This documentation site, it has everything. I'm sure you'll find Athena here. See, Athena is there. You want to create Athena resources, boom, you click on it, and then it shows you an example of how to do it. And then you can go to the argument section, read about what argument is required, go there, update the requirements, key and value. Okay, you want to work with Lambda, for example, it's all there. So even though, CloudFormation would always have new features before Terraform. So if Amazon is introducing a new technology, for example, CloudFormation would definitely have it first before Terraform. But Terraform, they're very, very quick to updating their code. Like I mentioned earlier, they release new versions literally almost every day or every week. Let's see what their release cycle is. Terraform release cycle. So, okay, they don't have it here, but because you can check for the different products, their release cycles, but they don't have it published. But I'm sure it's like every other week or so. They're always releasing something new. And the reason is because as AWS is releasing something, they are quick to just go ahead, make it available. They update their documentation, and it's a tool to rely on. Okay.
Yeah. Why I had to ask was because I know how it could be tough to set up a data pipeline, right? And for instance, with Athena, if you want to there's some queries you need to run and all those stuff. So that's why I really want to know how it would be to do with Terraform, if that is possible. But if they have this documentation, then I think it would be possible to do that. Just that it would be very tedious or kind of.
Well, I mean, see, with well-written documentations like this, with Google, nothing is really difficult, to be honest, because if you want to see a typical Terraform Athena examples, I am sure somebody has written some blog posts out there on it. Okay, building modern data warehouse with S3 Glue and Athena. You can check it out. And let's see, Terraform Athena data pipeline. Let me see. Let me put Medium and see if there is a Medium article on it. Building serverless data lake on AWS. That's something. Terraform on Athena database and all that. This is a Medium blog post. Okay, and this is, let's see if they have Terraform. Okay, so AWS CLI. So I'm just trying to give you, this is my thought process. Is that if I'm trying to do something new, check on Google first and see examples. So you can see this person has started writing things. This is a glue crawler. And let me see, Athena. Okay. So you can just key into examples like this, test it, and then begin to iterate over it to work for your own use case. So to be honest, there's a whole lot that you can do with Terraform. So what we're doing here is just to set you on the path to understand how you can go ahead and do anything, right? I hope that helps.
Yeah, thanks.
Okay. All right. So back to our infrastructure, we now see that Masterclass C has been created, and this is okay. So the resource has been created as well. All right. Now, if you take note of something, we have a state file that's been created. So there's a file here that's been created. So terraform.tf state. Okay. If you look through it, all the attributes that I mentioned is now set in here. Okay, you remember that time that when you use AWS CLI and you create something, it returns a JSON output and all that. This is what I was talking about. It saves all that information in a state file. So this state file is what it then uses to understand the state of your infrastructure at every point in time. Okay? So that if you want to create new resources on top of the VPC that has just been created right now, then you run a plan. At that point, it will tell you if your infrastructure is going to change, if something new is going to be added, if something is going to be destroyed. For example, if we go back here and we remove this Masterclass C and just do that and try to run and apply again. So remember, this apply is going to do a plan first of all, and then it will prompt you to say yes or no. Okay, so it's going to do a plan first. So now it's doing a refresh of the state. So it's going to read this state file, and that's how it will understand that, oh, something has changed, because in this state file, if I search for VPC, I'm looking for the tag section. You can see in this section, the tag, what it has is masterclass-c. Okay. And now you've changed the actual configuration. And that way it's going to be able to tell that, okay, you know, something is going to change. So I'm going to have to change this tag from C to this new value that we've just changed. And then you can see here it says 15 unchanged attributes. And that's hidden. Okay, because if it was going to show everything, it doesn't make sense. What we're interested in is to see what's actually going to be changed. So all the attributes is what is storing in this state file. Now, if we go back to our Terraform documentation, you can see the attributes section, which in the case of Athena, for example, there's attributes for ID. Now, there are some attributes that do not exist as part of our argument. Okay, every resource that gets created will have an ID once they've been created. And this is not something that you have control over. It's not something that you're going to put as part of the argument. So those kind of attributes would exist after it's been created. And so we don't know them ahead. Now, there's something called interpolation. It's also a Terraform concept. So interpolation means that if you want to create a resource and you want to use the part of the attribute of a different resource, then you can interpolate that new resource by referring to the attribute of that other resource. A typical example of that is this. So let's say we want to create, let me see if I can bring something else. Okay, this is a typical example. So let's bring the third one. Okay, so I'm going to add in here, let me minimize that. I'm going to add in here number 3, which is internet gateway. Okay, so part of our infrastructure, we need an internet gateway, right? And this internet gateway, we need it to be in the VPC that we've created. Now, imagine that we're running this for the first time. How do you think it's going to know that once this internet gateway is created, it's going to be in the same VPC that we're also creating here? Okay, so 2 things I want you to observe here. First is the fact that we are now interpolating an argument to say, well, the VPC ID for this internet gateway use the AWS VPC.main.id. So which is AWS VPC.main here, which is AWS VPC.main. And remember, when we're even doing our plan, it specifies it like that, AWS.VPC.main. Now, but the ID, we did specify here, and we don't even know about it. So what we're going to do here is we're going to interpolate the attributes of that VPC, which is the ID, which we don't know ahead of time. But because that information, I'm sure it's going to be here, you can see is going to be able to use it because it gets stored in the state file. So both the arguments and attribute, they all get stored in the state file and they all become, attributes ultimately, because you can then interpolate anything as long as it exists in the state file. So this ID, which is this random number, VPC hyphen whatever, which we never knew when we were creating this, now gets interpolated, and that way it can associate this internet gateway with that VPC. The second thing I want you to observe is that dependency thing that I mentioned earlier. So even though we're not specifically telling it that, well, this VPC has to be created before this internet gateway, Terraform is smart enough to know that, and it will use that graph, okay, because it plans that graph out initially, and then it will then know, oh, right, okay, I need to create this VPC first, and then I will create this gateway. But if you ever want to force that dependency, because sometimes you can do that. So there is an argument you can pass to Terraform, and that will be depends on. Okay, so it's a meta argument. So if we open it up, we can read this documentation, but an example of that is, let's see here. Okay, so you can put it depends on here, and then you give it, that resource that you want it to depend on. So sometimes you get to do that, but in most cases, it's okay to just leave it and let it run. But in some cases, if you know the logic of what you're trying to do, and you know that Terraform may just not know that this has to come first before that, then you can basically do that. And in some other cases as well, when you're copying the examples from Terraform documentation, they would have included it, because in some cases, they also know that Terraform cannot work out the dependencies, and then the depends on will come into play at that point. Okay, so now that we've introduced something else, I'll just press no here. So I'll cancel that apply, and then run Terraform apply again, because now we have an internet gateway. So what's going to happen is it says there's one to add, one to change, but there's nothing to destroy. We're not destroying anything. So what is going to be changed is the tags, and what's going to be added is the internet gateway. Okay. So if you notice, the ID of the internet gateway itself, it's going to be known after. We don't know it yet. But because there is an interpolation and the value exists in the state file, you can see it's already telling us even from the plan. So it knows that this gateway is going to be part of this VPC. And if I go back into this, this is our AWS CLI command. This is a typical example of interpolation where I think run instance image ID, yes. So sometimes imagine if we were to do this in AWS and we don't know the value of this AMI ID ahead of time. But as part of our Terraform code, we've written a resource block that actually creates this AMI. So we can interpolate that ID so that once that AMI gets created, then running that instance can just pick up the value of the ID and just interpolate and make use of it. Okay. So you can see the power of Terraform now, because if you were to do this in AWS CLI, wrap it around shell script or bash script, it's going to be a lot of work writing functions to, first of all, get this value, interpolate this and that. But with just a short block of code, with not a lot of programming, you can basically just get things done. And that's why it's called a configuration language, because you're basically just doing configuration. The actual programming itself is done in Golang, which is a much lower level thing. So if I click on yes to this, it will then begin to create that resource. And if we go back into AWS console and go to Internet Gateway. So this is the one that we're now creating now. So at the moment it's detached, and that's because it's still, okay, no, it's created. So if you refresh it now it's attached, and it's attached to the VPC. So this is how things will then start going on. So when you start a project like this, you can actually start by doing it one at a time, create files, give them numbers, but it comes to a point where you now want to start improving your code, and that's the refactor. Okay, so there was a project dedicated to refactoring as part of the project, which basically just gets you to refactor your code. And you should be doing a lot of that, even when you're working on your own. When you're starting a project, always start simple. You don't have to do anything complex at all. That's the best way to do any kind of programming. Okay, start easy, simple, keep it simple. Copy the example from Terraform documentation and basically just try it out without much changes. You can just change a few things in the arguments, try it out, see that it works, then go back to it and start improving on things. As a matter of fact, we can have all of this in one file. So if I remove that and I bring it here, and then I take this as well, I bring it here, just maybe put it at the top. Okay, I save that, and then this is now empty, I save this. This is now empty, I save this, which means I can, let me just cut it out. Just for now, save it here, and then remove this as well. Put it here. We'll bring them back. Just to show you, we can have everything in one file and then run our apply. So it's still going to work. So what I'm trying to say is, imagine if you had everything in one file from day one, things can easily start becoming complex, having all that file, keep appending and appending, you easily get to like hundreds of lines of code, which can be really confusing sometimes and hard to maintain. So you can start out splitting things out, and then later on start creating modules, which we'll get to later on. So that way you can even reduce, the multiple coding that you're doing and keep your code very dry, and you can easily reuse your code. We'll get to see all of that later. Okay, so let me see if there's any particular thing. Okay, so the next thing I would then want to show you is when you start working with Terraform initially, you basically work maybe as a solo engineer. Probably you're the only DevOps engineer in the team, and your state file gets stored on your laptop. That's okay initially when you start out. But the moment your team begins to grow and you have another engineer, there's one more person working with you in the team, it then doesn't make sense to keep the state file locally to you. Even when you're working as an individual, to be honest, right from day one, it doesn't still make sense to keep the state file locally to you, because what if your laptop crashes or something happens and you lose your entire state file? That's a lot of headache. There's no backup, even though it creates a backup for you locally, but it's still a single point of failure, because if your laptop crashes, both backup and main state file is gone. And state file is very, very, very important. Very important. Okay. So what do you do? So that's where the configuration of the backend comes in. Okay. So let's go back to what the configuration looked like before. Actually, what I'm going to do is, okay, let me destroy this just to keep things cool. Destroy. So this is another Terraform CLI command to use. Before I do the destroy, let me just run the other one, Terraform validate. So this Terraform validate basically checks your code just to say that whether your configuration is valid. Okay. All right. Now there's another one that you can, let me just do a few things. So I'm going to push this to the side. I'm going to push this to the side. Just make things look quite ugly. Okay. Push this to one side like that. Just make, this doesn't look good. This looks ugly. So there's a Terraform command you can run, which is a forms command. And if you run that, it basically helps you adjust everything. You can see it has just made them back to the way they should ideally look like. Okay, so, and it tells you what file it did the formatting on. Okay. All right, so let's do a destroy. So Terraform destroy. And this will then tell you what resource is going to destroy. So you can imagine having your entire infrastructure written as code like this, right? It makes it very easy for you. Even as a learner, you remember those days when you're configuring your Nginx, you're doing your tooling app, you're doing all those things, and you're scared of destroying your instances because you don't want to stop, when you come back, you don't want to start all over again, and you probably just leave your instance running and your cloud cost begins to rise. With Terraform, you don't get to do that because you can run things, put them there, test things out, do whatever you want to do, and destroy them so that your cloud cost can go down. So now we're going to destroy everything. It tells us, well, the plan says 0 to add, 0 to change, 2 to destroy. And it shows in red that these will be destroyed. The VPC is going to be destroyed. The internet gateway is going to be destroyed. And if I say yes, that destroys the whole thing. Okay. So what we're going to do is I'm going to remove this and then just start the whole thing again. Any questions so far while I'm trying to do this? Okay, that's good. All right, so I'll bring this over.
Sorry, I have a question, but I don't know. It's a little bit out of context.
Okay, yeah.
From I was working on project 19, then I came across an error. I don't know what the reason actually, but I can't SSH suddenly into an instance I created in the US East one. So I had to change to another region before I could SSH. But I still have my private key. So I wanted to know what could possibly be the problem.
So you created the resource in a particular region. So let's say US East 1, and then you couldn't SSH into that instance, but you could SSH into it from a different region. So I don't quite understand. Is that what the case is?
Yes, technically, I was creating this AMI from project 19.
Yes.
So at a point it gets stuck. It says SSH timeout. So I went on AWS to create an instance from that region, and I was using North Virginia region. So I found out that I couldn't SSH into the instance. So what I had to do to fix that error, I had to change to another region to be able to SSH into an instance, and that's when my error got solved. So I wanted to know what could possibly be the problem.
Okay, so your AMI is in what region?
It's in North Virginia region.
North Virginia. The EC2 you're creating is in what region?
Which one?
The EC2.
It's in North Virginia too.
Okay, so the EC2 is also in North Virginia.
Yes.
How about the SSH key that you created?
It's also in North Virginia.
Okay, well, we can probably take that offline because we'll need to dig into that to know exactly, why that's the case. Because if everything is in the same region, I'd expect that you should be able to SSH into it. But since you couldn't, it could be something else, but I don't know.
What I'm thinking, just a suggestion, maybe the HEMI ID took may be different from one particular region to the other. That's what I'm thinking anyways.
But the EC2 got created from the AMI. So you're talking about the base AMI ID, right? That
Yeah.
he used to create
because they are different from each region.
Yes.
Can I comment on the problem, because I actually tried to debug that problem with him, with Hassan.
Okay.
So what we actually did, initially he was trying to use Packer to build his AMI in US East region, if I'm correct. So along the line, it had SSH timeout. So when both of us were trying to debug the issue, we actually visited some articles. So then I told him, since it has to do with SSH, so we tried creating an instance in that same region to manually SSH into it to see if that's the issue. So we found out that was the issue, that we couldn't SSH even manually.
Right.
That's the Packer. So he told me that he has experienced that kind of stuff before, that if he changed to another region, he'll be able to SSH. So that's the problem. So he's trying to know why that problem happened initially, just to learn from it.
So let me understand. So you created this this EC2 from a particular image, yes? And
no, we didn't use we used an image from AWS this time around, just to debug the SSH problem. Yeah.
Okay, and still you couldn't SSH into it.
Yes.
Okay. And how were you able to eventually SSH into it?
He actually decided to create it in another region.
Okay, you created the EC2 in another
region.
Yes. Right. Okay. Now I get what you're saying. So when you created the instance in a particular region, it got created, it got initialized, everything happened fine, but still you couldn't SSH into it.
No, actually, it would not finish it won't finish everything.
Okay. The initialization would not complete.
Yes, it won't complete.
Okay.
But the only reason it didn't get completed was because of the SSH issue.
Okay.
Maybe the daemon is down, something like that.
I think so. So I changed to a new region, and everything got completed. I made all the other AMIs.
Yeah. Well, don't be surprised that if you try it again, maybe next week or some other time, the same thing that didn't work before may not work. Okay. And that's why when you're designing your infrastructure, you're considering multiple availability zones for different things. It could be a particular problem with that particular region. You never know. Or it could also be the fact that that AMI itself doesn't exist in that region, and then you go to another region, it exists there. It could be so many things. It could be, there's so many things we don't even know because we don't have the visibility into what exactly is going on with AWS infrastructure, and that's why when you're designing your infrastructures, you're putting in your mind disaster recovery solutions, high availability, all those kind of things, and testing things out as well. Okay. Now, one thing that you may do in situations like that, if it's related to that particular AMI in that region, you could, and you don't want to create resources in another region, you could then create the EC2 instance in the region that works, and then create your own golden AMI out of that and then make it available in the other region. Then you can create the EC2 in that region, and then, you know, it can work. So, but specifically to debug specifically why that problem is, you know, one might need to dig further into it. But top of my head, these are things I may, you know, I could think of. Okay.
Just to add, from what I got from one of the videos that I watched on AWS course, that North Virginia region happens to be the most up and down something region, because it gets new releases. It's the first from the man. It gets first releases always, which means it's almost down before it starts trickling down to other regions.
So it's very busy.
Yes, that could be one of the problems why he has having.
Yeah. So that's why I said, you know, you could try the same thing again next week and it's going to work. So it could be a temporary network issue. You know, it could be anything.
Yes. Yes.
Yeah.
Please, I have a quick question.
Sure.
Yes. I'm thinking before we actually destroy a job, in order to be on the safe side, isn't it ideal to look for the job log, then apply, include that parameter as part of the destroy command to be on the safe side?
Sorry, I'm lost. So to include what parameter?
Okay, so the job ID itself, because for every plan we run, that I'm sure there should be an ID associated with each plan. So to be on the safe side,
yeah,
it's ideal for us to get the ID first. Then when we run the command destroy, then we can include that particular ID that we want to destroy to that command, instead of just saying, oh, destroy Terraform destroy and it's going to destroy the plan. Why not, to be on the safe side, look at the log first and get the log ID, then we apply to the destroy command.
Okay, so first of all, for you to think of destroying anything at all, you are the one that you're typing your destroy. It means you want to destroy that infrastructure, right? And if you're dealing with multiple environments, of course, you then have to be careful so that you don't destroy an environment that you don't intend to destroy, right? Because you may want to destroy your dev environment, but leave production. But the same dev and production share the same code base, right? So what you're saying is, how can we ensure that we're not inadvertently destroying an environment that we don't intend to destroy? Well, so, I mean, this is best answered when you now start seeing how Terraform works in a pipeline, because ideally, it's not something you even want to be doing on your terminal. You shouldn't even be running Terraform command from your terminal. When you're working in a team, in an organization, it should be highly discouraged for developers to be running Terraform apply, Terraform destroy, all those kind of commands from your terminal. Those commands should never be run from your terminal. It should only run through a pipeline, because you would have written the pipeline much carefully that you may even write it to the point where you can never run a destroy.
Right.
Okay, your pipeline, every time it's triggered, there is no option for destroy. So there's no way it's ever going to destroy anything. But even if for some reason you've created your pipeline to have a destroy, then you can have extra caution, whereby, and this is where the whole idea around continuous delivery comes in, okay? Where you still have to click to continue with that that particular job. So at the point you're doing your destroy, remember it shows you something like this, where you would review before you eventually now click on yes and say, yes, go ahead. Now this can be passed out to an output, which will be a file, okay? And then that file can then be passed in at the time you are running the actual destroy. So all those kind of things are things that you get to do, with a pipeline. But yes, it's still part of being cautious. So of course you definitely have to be cautious with things like this, and the best way to do it is to ensure it's done through a pipeline, not from the terminal.
Oh, yeah. Thank you so much for the clarification. I appreciate it.
No problem. Okay. So the last thing I want us to quickly talk about, and then I'll give you some work to do for the week, and then we'll come back next weekend to complete this. We'll go through modules, we'll go through some functions and all that, and then we'll close it off for Terraform so that we can now prepare ourselves for the next round of the lessons. So it's the remote state. So if we go to our provider file, in that Terraform configuration, what we had initially was that we had this one right here, where we only had this required version. Yeah, remember that? Okay, so there is more argument that you can pass into it, and one is the backend. So there are different backends that you can configure and use with Terraform. So you can use S3, you can use Artifactory. Those are the two major ones I've actually used, to be honest, in production, but mostly you would see S3 be used a lot. Okay. And then this has a prerequisite that your S3 bucket must already exist before you can do something like this. Otherwise, you're going to be having errors. So there's a bucket in my S3 account called Devops Masterclass. And in that bucket, it's going to create the state file. So there's a folder in that bucket that gets created, and then that state file that was created locally now can be stored here. The good thing with this approach is that anytime anyone else in your team is running Terraform, they will all read from the same state file. Because if it was local on your laptop, there is no way, Busayo or anyone else that we're working together will access my laptop. There's no way. So there has to be a remote place where everyone in the team would have access to. So as long as your IAM credentials that you're using to run Terraform can access this bucket, then it will go ahead and read the state file. And that way it can tell you if something is going to be changed, it's going to be added, or it's going to be destroyed. Okay. So when you now run your Terraform init this time, what you will notice is it will now initialize the backend. And you see here, it says successfully configure the S3 backend. So this time around, the state file is not going to be created locally. Okay. The only thing that will be created is this .terraform folder. So, well, for now, you're seeing the state file here, but it's going to move it to S3 later on. But what I was going to show is the plugin. So it's still trying to download the plugin. You put the plugin here. And then when you start creating your resources, the state file itself will be moved to S3. Okay, so now let's do an apply. And if you have done, I think it's project 16 or 17, there is still another component, which is the DynamoDB that handles the locking. So this lock also can help you to ensure that when you're running your apply, another member of the team is not going to be running at the same time, because that way you can destroy things. So if I'm running, you're running, another person is running, all at the same time, that's disastrous. So there is a DynamoDB configuration you can do as well that stores the locking information, so that when I finish my execution, it releases the lock, and that way it would allow another person to run. So the way Terraform handles that is it stores locking information in the database, and it would always check in that database whether or not another person can run. Okay, so if I now run that, I think someone was raising up his hand just now.
Yes.
Okay.
Okay, it's just a quick question. You made mention of creating S3 buckets for backend for Terraform. We're going to do that manually before we start the configuration within the configuration file.
Yeah, so what I've seen, the way I've seen that happen mostly is okay, 1 second. Okay, so this is the S3 bucket, and this is the Terraform state, and now you can see the state file. So what I have seen happen most times is, some teams will have 2 Terraform setup. So one is going to be dedicated to everything that has to do with bootstrapping. So you can name it like a bootstrap of infrastructure, and that will be the one that will create your S3 ahead. Okay. And then you have another Terraform, which will now handle the whole infrastructure. So that's one way to do it. The other way is you can have the same infrastructure, but you now have to put some kind of logic. So the logic will be because it will be wrapped into some kind of a shell script. So you're not going to be able to run Terraform directly. Okay, it will be a wrapper around a shell script. So in that shell script, there will be a section that will do the initial bootstrapping, which will create the S3 bucket. Once that S3 bucket gets created, it will then pass it on to the next phase of infrastructure, which will run Terraform apply and everything. It's exactly what I explained at first. The only difference this time is that you're not having 2 different repositories. It's still the same repository, but you're now running your Terraform around a bash script that wraps around it. So in that case, you won't be running Terraform apply, whatever. You can create a shell script and you can call it, let's say, you can just say Dare Terraform.sh, something like that, okay? And then you can now configure that shell script to have its own parameter. So a parameter to it can be Bootstrap, okay? So to bootstrap it, it knows that part of the shell script will run the bootstrapping. And if you bootstrap the first time and you now want to carry on running your infrastructure, you can put another, flag to it to say provision. Okay, and then you can then have your own that says maybe plan, or you want to do apply. So within that shell script, it will have, Terraform apply, Terraform plan, and all that will be taken from the argument that you pass into that shell script. So I've seen that happen as well. So those are ways in which you can handle things like that. In some cases, I've seen people even wrap Terraform around. Excuse me.
Bless you.
Thank you. People wrap Terraform with Ansible, where Ansible actually triggers Terraform. Okay, and then you can have playbooks dedicated to bootstrapping, another one dedicated to provisioning, and so there's a lot of crazy things that people do. However it works for you, you can just go ahead, try things out, and go as crazy as you think you can possibly can. As long as it works and it satisfies your requirements, by all means you go. If your team is very small, you don't really care about all those fancy things, you can start up simple, run your Terraform plan, Terraform command, separately, manually create your S3 bucket, because to be honest, that's the only time you ever have to do anything manually. So there's nothing wrong with doing that either, because you just create it manually and that's the end of it, But it doesn't mean that over time, maybe your project has been live for more than a year and you now have time to improve things. Then you can start writing shell scripts, wrap things around it, do all sort of fancy things, So that's how things generally work.
Thank you. Yeah.
Cool. All right. So now, even though this state file is here, yeah. So it says backend and everything, but it's not something to really care about much because I can even delete this .terraform folder, okay, and run my init again. Okay, everything is in S3, and at this point, you won't see that state file again. So you can then carry on creating more resources and all that. So what you can do is you can switch into the main branch, see all the different resources. I mean, the whole of this week, practice this, try things out, look for the code, try to understand the logic behind all the different things that have been created. Go to Terraform documentation, read about the arguments, the attributes, how everything connects together. Okay, so that next week, what we will do is we'll just run the whole infrastructure. We'll go through all the code, run the whole infrastructure, see how everything works, and then try to modularize it, improve the code, work with some functions, and say a few more Terraform CLI commands, and that's it. So this is where we're going to end today's class, guys. So if you have any more questions, we can still take a few more questions, but otherwise, I would say thank you very much for your. Yes.
I have a question, please.
Okay.
Just a question I was asked in the interview.
Okay.
You're working on a project, and it just like you are running out of time, and you won't be able to meet up with a deadline. What will you do?
Okay. Is that it? That's just the question.
Yeah, that's just a question.
Okay. Well, first of all, communication. So you should never sit on a task. For example, you're running in a sprint, and usually a sprint can be 2 weeks. And you've been working on this ticket from the start of the sprint. It's almost the end of the sprint, and you're still working on it, and you can tell that you can't finish this in that sprint. Taking that task to the next sprint is not good. Scrum Masters will frown at things like that if it happens a lot, because it means that they didn't size the tickets very well before they put it in the sprint. Because ideally, when they do sprint planning, things should be planned properly that can be finished in that sprint. So if there's any chances that things will not get finished in that sprint, that ticket ideally should be broken down so that the part of the task that can be finished in that sprint is what the team will focus on. So in a situation where you've now picked up this ticket and you've been working on it, and it's almost the end of the sprint and you can't deliver, it will be very disappointing at the end of the sprint, and then you are breaking it to the entire team that you can't finish it. There's nothing wrong in speaking out early, okay? Communication is the most important thing here that he wants you to talk about. You have to speak out early. You have to get help. DevOps engineers should not be working in silos. If you need help, speak out. A healthy DevOps team should not ever encourage a situation where people in the team cannot be reached out to. If you're struggling with things, I'm sure, some of you may have experienced it. There are some people that are not so nice in the team where, you even be scared to walk up to them to get help. But ideally, it shouldn't be like that. You should walk up to people. You should try to get help. Speak to your Scrum Master. I'm trying to do this. I'm trying to, I'm blocked on this. Your Scrum Master will do the best that he can to get you help. So if you're able to do that early days in the sprints, you realize that, because sometimes what you're struggling with could just be that another pair of eyes can just quickly point you to a direction. It doesn't mean the person will sit down doing the work for you. A more experienced guy could look at what you're trying to do, give you some ideas that can point you in the right direction. It doesn't mean that you don't know what you're doing. I mean, you must have gone through interview before they hired you. So the chances are you're not dumb. You're not, it's not like you're not smart or anything. You're smart. Okay. But at the end of the day, these things, no one knows it all. We all learn from each other, and DevOps is very hard. We all know that. So we need each other. So I may need your help today. In next sprint, it could be you needing my help, And so it's very important that there's a healthy team, that everyone is nice to each other. You can always walk up to people, share ideas, and also that's why things like peer review also comes in. So as part of the Scrum ceremonies in the team, you will also have situations where you do peer reviews. So you've worked on the Terraform code. At the end of the sprint, there is a meeting where everyone comes together, you share your screen, and you walk your team through what you've done, how you've done it, the thought process, and everybody learns from it, So before that sprint review, it's something that you can also do with some other members of your team. But obviously, you want to be careful with this. You don't want to stress other people. You don't want to unnecessarily keep going back to them, eating into their time. But reasonably, you can always get help from people, and and that's I'm sure that's the answer the person was expecting from you.
I think that's the best. Because another thing I is just a suggestion. I think if you're working within a team, you have to actually have this kind of a relationship, close relationship with your team member. This gives you a kind of space that you can actually go to them and say, okay, I'm having a problem. Do you have kind of a solution? So I think that's the best way, which is the communication, then create a kind of interaction within your team member.
Absolutely. Yeah. Cool.
Sorry, another question before you close. Still on the interview, just like another question was that you are working on a project and you have 2 new tickets and they are of high priority. Which of them will you attend to first?
So you have 2 tickets that are both high priorities.
Yeah.
Which one would you attend to first?
Yeah.
Okay. So the way I would answer this is I would give them an example of a project management tool that is used or that I'm familiar with. So if you're working with Jira, for example, and you've created a sprint, you've pulled all the tickets in the sprint, you can't have 2 tickets that are at the same level of priority. One will always be before the other. So it's so obvious that the one at the top is the one that is of higher priority, and that's the one I'm going to work on before the other one. So except the team agrees and says, oh no, we need this to happen first, it has to go higher. But that's not your job. The Scrum Master would have worked with the product owner or solutions architect or whoever they're planning the sprint with, and they would have highlighted the priorities in the team, for the team in that sprint. So you as an engineer, you're coming in, you're going into the ticket, you look at the board, you would see all the tickets in order of priority. Some of them would have been taken by other engineers in the team. You would have seen that, oh, this is assigned to Wale, this is assigned to Nick, this is assigned to this person. Oh, this has not been assigned to anyone. That's the next in the order of priority, and that's the one I'm going to work on.
Yeah, because that's the answer I gave them that day. And the man was like, he was looking at me. I said, within me, and I knew quite well that at least one will be of high priority than the other one. There is no way the 2 of them will be of the same level. Yeah.
Exactly. Yeah. Cool.
Thank you very much.
I hope you got the job.
Well, what I did, because I just put 5 months to test the environment, but the feedback I'm getting from them is that my experience is not that big, 5 months. So they're kind of looking like 2-3 years. But I'm kind of like, let me finish the project first, then I'll increase my years of experience.
Don't worry. Once you finish all the projects, right? What you're doing is very good because you're putting, the experience level and everything now. And once you finish the projects, you can then, refactor your CV. But the risk with what you've done is that the moment your CV is out there, then it's in the public space. So you can't have a 5-month CV now, and let's say you finish this program in 3 months, and then you want to change it now to 1 year or 2 years experience. That's where some recruiters may frown at, because a recruiter may have seen your 5-month CV and then seen another one, and then may start wondering, okay, what's going on? Do you understand?
Yeah. But
I think it can pull it down.
Yeah.
If you are using LinkedIn, it can pull it down. Then
that's fine. If you're using LinkedIn, yes, but if you're in the UK and you're using things like JobServe, you're using there's quite a number of them. CW Job,
Civil Library, and just
make it history. Trust me.
But I'm kind of looking at the aspect of like changing the my email, my name, swapping it around, and pull the CV down.
So what I've seen people do initially when they're trying to test the market is they use different names entirely, because you're just trying the market. So let's say, for example, your name is, in my case, Dario Funlayo, right? And I know I just want to do a test, okay? And my middle name is David. I probably won't use Dario Funlayo straight like that. I'll use David Olu. Okay. Just in case that job comes through and the test becomes real. If that happens, well, it's still my name, right? Just a CV. So when they're doing background check and all that, they have my ID, they say it's still the same. So those are the kind of tricks that you can use.
All right.
Yeah, Dario.
Hi, Dario.
So, yeah, let me just add this last one. It's not a difficult one. I was in one interview, the same like what our fellow colleague just said. That was last week. I don't know.
Okay, so the question was, if you want to attach a volume to an instance in AWS, how do you do that?
Yes.
That was right?
Yes.
Okay. So it's a good that you mentioned other things around partitioning, mounting NFS and all that, but that's not exactly what, he was trying to get from you.
Yeah.
What he was trying to get from you, first of all, is, how you attach a volume. First, you can do it manually from the console. You can, create the volume, and then you can attach the volume to it. Some of the things that he's interested to know is making sure that the volume you created is in the same availability zone as the EC2. Yeah? It's particular about AWS at this point, the process of attaching the volume in AWS. Then you can go ahead and talk about if you wanted to automate that process. Okay, so if you're working with Terraform, things like that, you can provision an EC2 instance, and then you can also have the volume attachment and all that done as part of your Terraform configuration. That is automating the process. Then after you've mentioned things like that, then you can then start talking about further configuration of that volume, partitioning, okay? If you need to create multiple volumes and pull them in using LVM to have different disks and those kind of things, that is just you now expressing further to show your depth of experience.
Okay? Yeah, that's true. That's true. The thing is, we were at that point. We were. He was like trying to know my know-how. What is my know-how in Linux?
In what?
How can I rate my knowledge in Linux?
Linux, okay.
Yeah, so that was where he started asking such a question. The thing is, I really didn't want to be stuck because we were talking about Linux, like to add the volume using command line.
Commands and all that, yes.
So to be candid, I really, most of the time, I just go and I create a volume from AWS. But since we were talking about Linux at that point, I did not want to be stuck. So I went on just saying, okay, after you create the volume, you attach it. Then,
you haven't done bad, to be honest, and obviously, if I didn't know that you've done these projects, on our platform and all that, and I'm hearing you say things like LVM, NFS, partition and all that, immediately I would just conclude.
I've done it. I've obviously created and I attach until I'm going further.
Exactly. Which is good.
Yeah. Thank you.
All right, cool.
Hi, Darren.
Hello.
Yeah, please, I have a question. I don't know why it's really a question, but like I'm preparing for an interview, right? From what the company's recruiter told me, that I'll be working with a team that are developing APIs for maybe their applications.
Yes.
So I just want to know, as a cloud engineer, right, what will really be my role around that team developing APIs, so it will help me better to prepare, like know where I have to go and concentrate.
Okay. So to be honest, this kind of interview, you will shine very well after we've gone through, from projects 20 all the way to 30, because that actually focuses on things like that. And modern software teams developing APIs, they love to work in the world of containerization and Kubernetes, because creating microservices, all of them exposing APIs, interacting with each other, it works very well with Kubernetes. So be prepared to answer questions around Kubernetes, okay? But what you will be doing as a DevOps engineer in that team will be pretty much what we're doing right now, in the sense of provisioning infrastructure, except that it is not this infrastructure we're doing right now. It'll be more around Kubernetes. So you provision infrastructure in Kubernetes, and then you will help them deploy applications into Kubernetes. And that's where, pipelines around working with Docker images, Docker file, working with Helm, deploying different tools, and then working within Kubernetes itself, configuring service mesh, configuring ingresses, path-based routing, upgrades, rolling updates, all those kind of things are things that you'll be doing, in that space. So it's still early days as part of this training, but in the next phase after we've finished Terraform, that's the part that we'll be focusing on. Okay.
Yeah, Darren.
Yes.
Yeah. Coming back to the question about volume, right? Following the Terraform link from Dare.io, that goes to LinkedIn. So following that guy in LinkedIn, he explained something of which, when you go to on the Terraform documentation, create volumes, gives you there's a format where you create a bash or a bash script first with it, and then you just run one command, then it will create the volume. There you can increase the volume even to 30. From this example, he increased it to 30. So I'm asking, is that maybe can you use that format, like create that bash and then run it on a Linux terminal?
To increase the volume size or to create a new?
Yeah, like to create a new volume.
Yeah, I mean, it's because whatever that bash script is doing, it could as well be wrapped around AWS CLI that interacts with AWS, provisions the volume, and does other things, mounting it, partitioning it, whatever. Okay.
Yeah.
At the end of the day, if that solves the problem you're trying to do in your team, okay, that may be okay. But when you work within a team, there is what is called the sprint planning, where everyone is talking about, what we're going to be doing in the next sprint. And let's say this ticket comes up where we need to automate provisioning of volumes and all that.
Yeah.
And you're assigned that ticket, okay?
Yeah.
At that point, the team, everyone, you're planning that ticket because it could be one of those tickets where you have to create subtasks. And part of the subtask could be, to write a shell script to do that. At that point, if somebody else has a concern with that, in that meeting, you will all talk about it. Because someone may raise a point and say, do we really want to use shell script to do things like this? We're already using Terraform. Why do we want to be writing shell scripts to provision volumes when we're already using Terraform? So in that case, because at the end of the day, there's so many things, so many ways to achieve the same thing in this IT world. You just have to find the one that works best with your team. So if your team does not use Terraform at all, of course, using shell for that is a good solution. But if you're already using Terraform, why do you want to now introduce bash script to do things like that? First of all, you're already using Terraform. Your Terraform code is not aware of this new thing you're bringing. And when you're running Terraform updates, any update to your Terraform, or maybe it's part of an auto-scaling group, it goes down, it's just not going to be consistent.
Yeah.
Do you understand? But if everything is part of your Terraform, you are very sure that anytime you run your Terraform, your infrastructure is going to be exactly how you want it to be. Okay?
I get it. My question was more linked to answering the question asked by during the interview, and it is more geared on creating volumes on Linux that I think I've not done, and I don't know how.
Okay. Yeah. So So creating volumes on Linux, but you must have done that as part of the early projects, though.
What I know is creating it manually through AWS, not like typing scripts.
Automate the process, writing scripts. Okay.
Yeah, that's what I mean.
Yes, of course. I mean, it's a very good thing. You can do it like that. If you're not talking about Terraform, all those things, you can definitely do it as part of a script, because anything you can do from the console,
yes,
you can also do using CLI, and you can put that CLI in the bash scripts.
Yeah,
and run that script at any one.
Yeah.
What you should bear in mind is when you're running that bash script, if you just put your CLI there, it may not be idempotent. Remember we talked about idempotent.
Yeah. So if you run it 2-3 times, then you're going to create 3, 4, 5.
Exactly. So that's the point where you now have to put the idempotent logic in your bash script, because you can do that. So you can write some if functions first. If
there is already a volume.
Exactly.
Yeah, in this example particularly, there is an if function on it. So it
that means idempotent.
Yes, it first checks whether there is a volume. If there is, then it doesn't increase. But if there is not, then it takes it.
Exactly. That's it. That's a brilliant approach.
Yeah. Thank you.
All right. Cool. Okay.
Hi, Darren. Hi,
Hello.
Darren.
Hi.
Sorry to cut you short. So my question is this: I sent out my resume today.
Okay.
To friend to look through, and then he gave me feedback. He said my resume was all over the place. So my question really is, do you mind doing a resume review, or do you mind sharing with us a template that is structured by the projects you have accomplished? So more like projects 1 to 20, this is what your resume should look like. These are the skills you should touch on. Not necessarily not necessarily something verbatim. You understand? More like a guide. So if you're done with projects 1 to 15, this is what it should look like. If you're done with projects 1 to 20, this is what it should look like. If you're done with projects 1 to 40, this is what it should look like. So that's pretty much my own question now. Because I think almost everybody will be having that same issue, or could be having that same issue.
So that's part of the service we render as part of what we do. So there's an add-on section to this after you've completed all your 30 projects and all that, and you're ready to start looking for work. It's an add-on service. If you need it now, it's something you can reach out to our support team, and then we will look at your CV, help you with your CV, your job hunts, part of the things we even do. You may not even bother looking for work. Okay. We'll help you go through the whole CV thing, and we'll take care of the whole job search and all that for you. Okay. So if that's a service that you're interested in, after the whole call, we can talk about it. You can reach out to Solomon, or the support team, we'll take care of all that for you. So a lot of people take that service actually, and it works fine, because the way we'll write your CV for you, you can't go wrong with it, because it's a template that we have used several times, and it's not the same with any other person. It's always going to be unique. Yours is going to be unique. So that's, the recruiter will not see your CV and will look like, but I've seen another person use the same CV, so yeah.
I think, I have a question on this CV stuff. So I find that you guys should write it, but for me, mine is kind of peculiar, but I believe it will also work for my advantage. Okay, I'm kind of a senior software developer, so and had a bit of DevOps experience because I had to function as both where I worked before the company I'm working with now. So I don't know. Sometimes I'm thinking, if I have two CVs, right? There was that I was trying to apply for a DevOps position with a bit of experience I had, but I later abandoned it. And currently, I'm still working as a software developer. So now I'm like, how am I going to manage both? How am I going to do it? Like, to make the software side be an advantage to if I'm applying for a DevOps position. And like you said, in UK, I've actually submitted my CV to some of this stuff you mentioned, but I never knew that they wouldn't work with anybody from Lagos. They don't like people outside UK. They want people inside UK. So my CV is already there as a software guy. So I don't know how I'm gonna do it, to make it.
You're in a better position because you're a typical example of people, kind of people that companies want to hire for DevOps, because you stand a better chance than a lot of people like myself, even because I don't come from the software background. But most companies, they want to hire, well, I wouldn't say most companies, but some companies want to hire software engineers that are also DevOps engineers, if that makes sense, And to be honest, DevOps will be easy for people like yourself because you already have the programming knowledge and things like that. But that being said, your problem is not even a problem at all. It's not even something to worry about, because you can still have your CV to reflect that you do have programming experience, and now your focus is on DevOps. But even while you were working as a programmer, you've been doing DevOps related stuff, but a part of your CV still has to focus on a period that all you were doing was DevOps. Because if it's still showing that you're working as a software plus DevOps, they'll consider you as a software engineer and not a DevOps engineer. They'll still want you to have spent the time focusing only on DevOps, even if it's just for 1 year. Okay, there has to be a section in your CV that actually focuses only on DevOps.
Oh, that's the area I have a challenge with. Well, you have to tweak the CV kind of. So, yeah. All right. Okay, you guys, like you said,